So once again, Prashanth Kuna here. Today we'll be discussing about basic electrical engineering. So some of the definitions what we'll be discussing in basic electrical engineering is, first we'll be discussing about charge. Charge, it is the characteristic property of matter. It is the characteristic property of a matter. So my charge can be positive. My charge can be positive. Charge is negative. Charge is negative. And my charge can be neutral. My charge can be neutral. So charge, it is the characteristic property of the matter. Charge can be positive, negative, and neutral. When we are coming to current, it is the rate of change. It is the rate of change of charge. It is the rate of change of charge per unit second. So I can write I is equal to Q by T. The unit of charge, the unit of current is ampere. The unit of current is ampere. If my current is changing with respect to time, I can write I is equal to dq by dt. I is equal to dq by dt. Then we will be discussing about potential or voltage. Potential or voltage. When we are discussing about the potential or the voltage, it is the amount of work done. It is the amount of work done in moving a unit positive charge from infinity to that point in the field. So simply I can write V is equal to W by Q, where V is the potential or the voltage. It is the amount of work done in moving a unit positive charge from infinity to the point in the field. So V is equal to W by Q. The unit of voltage is volts. V-O-L-T-S. If my voltage is changing with respect to time, if voltage is changing, if my voltage is changing with respect to time, then I can write V is equal to dW by dQ, where dW is the small amount of work done and dQ is nothing but simply a small amount of charge. So here potential or voltage, it is the amount of work done in moving a unit positive charge from infinity to that point in the field, and we can write V is equal to W by Q. The unit of voltage is volts, and when we are coming, if the voltage is changing with respect to time, I can write V is equal to dW by dQ. In the same case, if I want to define potential difference, it is the amount of work done in moving a unit positive charge in moving a unit positive charge from one point to another point. One point to another point. So here once again, potential difference is the amount of work done in moving a unit positive charge from one point to another point. Here also I can write V is equal to W by Q. So once again, the unit of potential difference, whatever we are having, the unit of potential difference is volts only. It is volts only. So these are the definitions which we will be discussing regarding the basic electrical engineering. Now, when we are coming to the classification, so next the important topic what we are having is, it is very, very important. It will be coming in the exam. He will be asking, briefly explain the classification of elements. So here, when I am coming for the classification of network elements, when I am coming to the classification of network elements, so here they are classified as active elements. They are classified as active elements. I am having passive elements also. I am having active elements as well as passive elements also I am having. Now when we are coming to the active elements, they are also said to be the sources. They are said to be the sources of energy. They are said to be the sources of energy. When we are coming to the passive elements, they are said to be the sink elements. That means they will be absorbing the energy. They will be absorbing the energy. So further classification, what will happen? My active elements, I will be having voltage source. I am having, and I am having current source. I am having voltage source and I am having current source I am having. Now when we are coming to the passive elements, they are further classified as resistor. They are classified as resistor. They are classified into inductor, and then they are classified as capacitor. So here when we are coming to the classification of the network elements, mainly they are divided into active elements and passive elements. Active elements are the energy sources and passive elements are the sink elements. And when we are further classifying active elements, again they are divided into voltage source and current source, and my passive elements are divided into resistor, inductor and capacitor. So once again further classification if I am going, so once again my voltage source is divided into dependent source. It is divided into dependent source, and here it is independent source. Dependent source and independent source. Dependent source and independent source. The same is applicable for case of the current sources also. Dependent sources I am having. Here I am having independent sources I am having. So this is the classification when we are coming for the active elements. This is nothing but network elements. Further, if I want to classify into some more briefly, so my elements are classified as passive elements. Passive elements I am having. I am having active elements I am having. Passive elements and active elements. As previously we have discussed, passive elements are nothing but simply they are the sinks. They will be absorbing the energy from the energy sources. Example I am having is R, L and C, which are resistor, inductor and capacitor. When we are coming to the active elements, as I said, these are the sources of energy. These are sources of energy. So here, as I said, we are having current source I am having. I am having current source I am having. And I am having voltage source I am having. I am having current source, and I am having voltage source. These are the things. And next, when we are coming to the further classification, they are classified as non-linear and linear. Non-linear and linear. When we are coming to the linear, the elements which obey Ohm's law are said to be linear elements, and the elements which does not obey Ohm's law are said to be the non-linear elements. So here, which obeys Ohm's law, and here which does not obey Ohm's law. So here they are classified as, once again they are further classified as linear elements and non-linear elements. Linear elements which obey Ohm's law, non-linear elements which does not obey Ohm's law. And further they are classified as unilateral. They are classified as unilateral. And bilateral. They have classified unilateral and bilateral. Now when we are coming to the unilateral, the best example I can give is, for unilateral element, example is diode. Suppose I am taking a diode like this. This is anode and this is cathode. Diode will conduct only in one direction. When the current is flowing from anode to cathode, it is allowing the current to flow. So, in forward bias, when it is allowing the current to flow, it is acting as a conductor. In the reverse bias, when the current is flowing from cathode to anode, in the reverse bias, it is not allowing the current to flow. That means it is acting as an insulator. So simply I can say here, by changing the direction of the current, the characteristic property of the element is changing. So the elements which change their characteristic properties by changing the direction of current are said to be unilateral elements. So once again listen here, ma. The elements which change their characteristic properties by changing the direction of the current are said to be unilateral elements. The best example which I have given is diode. In diode, in the forward bias, it is allowing the current to flow. When it is allowing the current to flow, it is acting as a conductor. When reverse bias, it is not allowing the current to flow. When it is not allowing the current to flow, it is acting as an insulator. So simply by changing the direction of the current, its characteristic property is changing. Now when we are coming to a bilateral element, the best example I can give is resistor. Suppose I am having a element resistor between A and B. My current is flowing from A to B. The property of the resistor is to stop the free flow of electrons. So when the current is flowing from A to B, it will be stopping the electrons. When current is flowing from B to A also, it will be stopping the free flow of electrons. So here what is happening? Even the current is flowing from A to B or B to A, the characteristic property of the element is not changing. That is to stop the free flow of electrons. So simply the elements which does not change its characteristic properties, by changing the direction of current are said to be bilateral elements. Now further, if they are classified, I can say these are lumped system. I am having lumped system, and I am having distributed system. I am having lumped system and distributed system. So simply, a lumped system is a system in which the elements of the system can be replaced. So here, it is a system in which elements can be replaced. The best example for lumped system I can give is a TV set. In a TV set, what will happen? I will be having a number of resistors, inductors and capacitors. If any of the resistor, inductor or capacitor is damaged, simply I can replace that. So simply, a lumped system is a system in which the elements of the system can be replaced. The best example which I can give is a TV set. A distributed system, it is a system in which elements cannot be replaced. It is a system in which the elements cannot be replaced. The best example for this I will be giving is a transmission line. So here in the transmission line, I think everybody will be seeing the electric poles. On the electric poles, we'll be having a cup-like structures we'll be having, which are said to be insulators. They are made up of ceramic. Once they are placed on the electric pole, means for the lifelong they cannot be removed here. So that's why a distributed system, it is a system in which the elements of the system cannot be replaced. The best example which I can give is a transmission line.